Hi and good everyone. Today I'm going to present my final year research project. The title of the research is Hybrid Polyacrylic Acid Hydrogel Bamboo Biochar for Ammonia Nitrogen Removal from Aqueous Solution. This presentation will be covering introduction, literature review, methodology, result and discussion, as well as conclusion and recommendation. Ammonia nitrogen is a compound that mainly can be found at urban runoff, domestic wastewater, and animal from wastewater. Excessive discharge of ammonia nitrogen from wastewater to receiving water can endanger the ecosystem by encouraging excessive growth of algae, thus reducing the total use of oxygen. There are many methods used to remove ammonia nitrogen from wastewater, and one of them is through absorption. Hydrogel are 3D polymer that can swell and hold large quantities of water while retaining its structure due to hydrophilic functional group. Hydrogel can be synthesized from natural polymer or synthetic polymer through physical or chemical cross-linking interaction. Hydrogel can be used in drug delivery, tissue engineering, as well as in wastewater treatment. Moving on to problem statement, the use of polyacrylic acid hydrogel is one of the alternatives to eliminate ammonia nitrogen from wastewater. However, to improve the absorption capacity, PAA hydrogel need further modification. Based on Cruise ETL 2018, the absorption capacity of PAA hydrogel was in the range of 8.8 to 32 mg per gram. The properties of biochar such as high surface area, surface functional group, and ion exchange capacity allow biochar to maximize its effectiveness as adsorbent. Therefore, this research focused on improving the absorption capacity by integrating biochar into polymeric structure of the PAA hydrogel. The objective of this research are to synthesize polyacrylic acid hydrogel bamboo biochar by varying the amount of bamboo biochar, to investigate the effect of varying bamboo biochar amount on the swelling properties of the hydrogel biochar, and to analyze the absorption kinetic of the ammonia nitrogen absorption using hydrogel biochar. In this research, hydrogel biochar was synthesized through free radical polymerization using acrylic acid as monomer, APS as initiator, and MBA as crosslinker. Water absorption were conducted at pH of 7, and lastly batch absorption were conducted using 50 ppm of ammonium chloride solution at 24-hour contact time and at pH of 7. Moving on to literature review. Literature review can be divided into 6 sections. However, in this presentation, I will be presenting the important parts. Firstly, preparation of hydrogel. Hydrogel can be synthesized through physical or chemical cross-linking interaction. However, cross-linking by free radical polymerization is one of the most common methods used to synthesize the hydrogel. Next, modification of hydrogel. Zheng and Wang 2009 prepare composite hydrogel by adding REC into chitosan grafted polyacrylic acid hydrogel for ammonia nitrogen absorption. The addition of 10% of REC into hydrogel increased the absorption capacity. However, the absorption capacity decreased with further increase the REC content. Secondly, Zheng and Wang 2010 added biotin into polymeric structure of PAA hydrogel. According to Zheng and Wang 2010, the absorption capacity increased as increasing the biotin amount up to 10%, which could be due to higher swelling ratio of the hydrogel composite. However, the absorption capacity decreased with further increase the biotin amount. And lastly, Zheng et al. 2009 prepared chitosan grafted PAA hydrogel atapalgate by varying the amount of atapalgate. The study showed that increasing amount of atapalgate up to 20% improved the absorption capacity, which could be due to the formation of a relative loose fibrous surface, larger amount of microspore, as well as higher pore size. However, further increasing the APT content reduced the absorption capacity because the pore size decreased due to being filled by the excess APT. The table shows the effect of biochar on the swelling properties. The swelling ratio increased as increasing the biochar content loading to 1%. However, the swelling ratio decreased when the amount of biochar was above 1%. Hydrogel biochar for ammonia nitrogen absorption made of polyacrylic acid crafted with chitosan and rice straw biochar were developed by Zhang, Tang, and Guan 2020 with equilibrium absorption capacity of 19.08 mg per gram, and follow pseudo-second order model with R-square value of 0.9978. Moving on to methodology. Firstly, the biochar were added into a solution containing monomer, initiator, and crosslinker. The solution were led to undergo free radical polymerization to form polyacrylic acid hydrogel biochar. Secondly, water absorption was conducted by immersing the hydrogen biochar into distilled water, and the swelling ratio were analyzed. And lastly, batch absorption were conducted using 50 ppm of ammonium chloride solution at 24-hour contact time, 200 rpm and 25 degrees Celsius. The sample were taken at 30 minutes, 1, 2, 4, 8 and 24 hours, and polyvinyl chloride, polyvinyl alcohol, mineral stabilizer and Nielsen reagent were added to analyze the residual concentration of the ammonia nitrogen. Moving on to result and discussion, hydrogen biochar was successfully synthesized through free radical polymerization by varying the amount of biochar. Next, the effect of time on the swelling ratio of the hydrogen biochar. At the initial stage of the absorption, the rate of swelling is faster due to availability of the water absorption capacity of the hydrogel. However, the hydrogen biochar achieved equilibrium water absorption after 4,320 minutes, indicating no water absorption and desorption occur. Next, the effect of varying biochar amount on swelling ratio. From the figure, adding 0.5% of biochar into hydrogel increased the swelling ratio. This is because the hydrophilic group in the hydrogel biochar were intensified by the presence of hydrophilic functional group from biochar surface, which facilitated the water absorption, thus increasing the swelling ratio. In addition, higher porosity of biochar provide more free volume for water to penetrate into the hydrogel. However, further increasing amount of biochar to 1 and 2% reduce the swelling ratio to 155% because excessive amount of biochar can aggregate and weaken biochar network synergetic interaction, thus reducing the water absorption. Next, the absorption capacity as a function of time. The hydrogen biochar achieved absorption capacity 3.39, 6.87 and 11.11 for hydrogen biochar 0.5, 1 and 2% respectively. Meanwhile, hydrogel and biochar show lower absorption capacity with 0.83 and 0.98 mg per gram respectively. Next, the effect of biochar content on the absorption capacity of the hydrogel biochar. From the figure, the absorption capacity increased as increasing the amount of biochar, which could be due to the formation of relative loose fibrous surface, larger amount of microspore, as well as the higher pore size. Absorption kinetic analysis were conducted using CDU first order and CDU second order model. From the table, the correlation coefficient R-square value is higher using CDU second order with R-square value of 0.9991 and 0.9997 for hydrogel biochar 1% and hydrogel biochar 2% respectively. And the equilibrium absorption capacity calculated from CDU second model was also closer to the experimental equilibrium absorption capacity. As conclusion, the hybrid polyacrylic acid hydrogel bamboo biochar was successfully synthesized through free radical polymerization. The addition of 0.5% of biochar into PA hydrogel improved the swelling ratio to 163%. However, the swelling ratio reduced from 163% to 155% when the biochar content increased from 0.5% to 2%. The absorption kinetic analysis revealed that the absorption of ammonium ion using PA hydrogel biochar followed the pseudo second order kinetic model based on the high R-square value and closer proximity to the experimental equilibrium absorption capacity. Pseudo second order assumed the absorption occurred through chemisorption. The absorption capacity was 3.39, 6.89 and 11.11 mg per gram for 0.5%, 1 and 2% of biochar respectively, compared to polyacrylic acid hydrogel with 0.83 mg per gram. Lastly, recommendation. Swelling ratio analysis at varying pH should be further studied to determine the ability of the hydrogen biochar to swell at different conditions. There are many factors affecting the efficiency of the absorption by hydrogen biochar, such as pH, initial concentration, dosage, and coexisting ion. Therefore, the absorption should be conducted at various parameters and conditions. And lastly, reusability and regenerating study of the hydrogel biochar should be further studied. That's all from me. Thank you.